In this video, I'll be going over Le Chatelier's principle and changes in concentration, temperature, and pressure. So the first example I will do will involve a change in concentration. And this is the chemical equation that I will be looking at. H2O2 decomposing to H2 and O2 while in equilibrium. So the first question we are asked is, what happens to the equilibrium when we increase the concentration of H2? So let me write that down. We increase the concentration of H2. That's what the square brackets mean. So we're asked, which way does the equilibrium shift when we increase H2? So we can use arrows to help us with this. It's the easiest way to do it, in my opinion. So initially, we increased the concentration of H2 right here. So I can write an arrow, we increased it. So the equilibrium, the system tries to compensate for this. So it then decreases the concentration of H2, and it decreases the concentration of O2. It decreases the concentration of the products to compensate for this increase of H2, and it increases the concentration of H2O2. So essentially, it shifted to the left and produced H2O2. So what happens when we increase H2 concentration? We shift to the left. Now, what would happen if we decreased the concentration of O2? Well, let me write that down and we can solve that. So what would happen if we decreased the concentration of O2? First, I'm going to erase these arrows so that it's easier for us to see what I'm doing. Okay, so we initially decrease the concentration of O2. So I'll write an arrow to indicate that. So we decrease the concentration of O2 initially. Then the equilibrium compensates for this and increases the amount of product being produced. So it increases the concentration of O2, it increases the concentration of O2, and so it has to decrease the concentration of reactant being produced. So we decrease the concentration of O2 here, so the equilibrium has to shift to the right to compensate for this decrease in the products. So we can say that it shifted to the right instead of the left this time. Okay, let's do one last example involving a change in concentration. This last example asks us, what will happen to the equilibrium when we increase the concentration of H2O2? So first, let's start by drawing the arrows. So first, we initially increase the concentration of H2O2. So then the equilibrium then decreases, or the system decreases the amount of H2O2 being produced, and it increases the amount of product being produced. So it increases H2 concentration, and it increases the O2 concentration to counteract that initial increase in H2O2. So the equilibrium is trying to, well, the system is trying to reach equilibrium again. And so by doing that, we shift to the right again. Okay, now let's see what happens when we change the temperature of the system. Just give me a second to draw everything out and I'll be right back. Okay, now that I've finished drawing the problem, we can begin. So this time we're doing changes in temperature, and the chemical equation is the exact same, but now we have a heat. or a delta H. So this equation, this chemical equation, produces heat. And the trick to this, the trick to doing these temperature problems is knowing whether or not it is an endothermic reaction or an exothermic reaction. So we are given the delta H, or the heat of the reaction, and it is a positive value for heat. So it's positive 187 kilojoules. So when you have a positive delta H, or a positive heat, that means that the reaction is endothermic. And you can say that the heat is a reactant because it is an endothermic reaction. If the delta H that it gave us was negative, so if it was negative 187 kilojoules, we can say that it is an exothermic reaction, and we can say that the heat is a product. So we could write the heat on the product side instead of a reactant. But for this question, we are given a positive value for the delta H, so we can say that heat is a reactant. Now that we know that, it is almost identical to the changes in concentration. So the first question we are asked is, what happens to the equilibrium when we increase the temperature of the system? So I'm going to do the same thing by drawing the arrows. So initially, we increase the temperature, or the heat, of the system. Okay, so then what the system does is it decreases the heat to compensate for that initial increase, because it wants to maintain equilibrium. So it decreases the reactants, the heat in the reactants, and it increases the heat in the products. So it increases there, and it increases there. So we can say that the equilibrium shifted to the right. Okay, now what happens if we decrease the temperature? So what if we are asked, what happens to the equilibrium when we decrease the temperature? So I'm just going to erase these arrows really quickly. It's going to be a little bit difficult. Okay, so let me fix this H really quickly, and then we can start it. Okay, so we decrease the temperature initially. So we decrease, we put a down arrow for the heat. So the system tries to compensate for this by shifting to the left. It shifts to the left to compensate for that initial decrease in heat. So it shifts to the left. That means the products go down and the reactants go up, because we are trying to compensate for that initial decrease. So the equilibrium wants to shift to the left. It's just the opposite of what I just did in the last problem here. Okay, now that we've done changes in temperature, I'm going to do changes in pressure, but I'm going to erase everything here and draw that, and I'll be right back. Okay, I've finished drawing the problem out, so we can start. So this time we're dealing with changes in pressure instead of temperature, and we have the same chemical equation as before, this H2O2 decomposing into H2 and O2, but this time we're dealing with pressure. And pressure is a little bit different than temperature and concentration, and you'll see why. So the first question we're going to start with is, what happens to the equilibrium when we decrease the total pressure of the system? So before I start drawing arrows and doing that stuff, we have to know that pressure deals with moles. So when we decrease the pressure of a system, the equilibrium will shift to the side with more moles of gas. So whenever you're solving these pressure problems, if it says where does the equilibrium shift when we decrease the pressure, Well, the equilibrium shifts to the side with more moles of gas. So what that means is we look at the coefficients of the substances in the chemical equation, and whichever side, the products or the reactants, that has more moles of gas, that is the side that it's going to shift towards. So let's look. We have 2 moles of gas here. We have one, like there's an invisible one here and an invisible one here. So that's 2 moles of gas. So we know immediately this has more moles of gas than this side. So it's obviously going to shift to the right. So we don't even have to use arrows for this question. We can just logically think through this. So if we decrease the pressure, we shift to the side with more moles of gas. So that would be the right side. The right side, the products. Okay, so what happens when we increase the pressure? Well, it's the opposite. So when we increase the pressure, the equilibrium will shift to the side with less moles of gas. So on the left hand side here, in the reactants, we have 0 moles of gas. We have 1 mole of liquid H2O2 but 0 moles of gas. So right away we can say that the equilibrium will shift to the left because it has less moles of gas. So just remember when you're doing these problems, when you're doing the change in pressure type problems, I should say, that it corresponds to the amount of moles in the equation. So you don't even have to write arrows or anything like that. You just got to remember that it deals with moles and the amount of the moles. And sometimes these kind of questions will ask changes in volume. So instead of a change in pressure, temperature, concentration, they'll ask for a change in volume. So they'll say, okay, what happens to the system when we increase volume? And pressure and volume are inversely proportional. So if it says, okay, what happens to the equilibrium when we increase volume? That means what happens to the equilibrium when we decrease pressure. So you could just treat it as the opposite. So you could, if it says increase in volume, what happens? Just remember, okay, what happens when we decrease pressure? That's the same thing as an increase in volume. So that would shift to the right if it increased volume. And so if it decreased volume, that would correspond to an increase in pressure, and it would shift left. So just remember, volume and pressure are inversely proportional, and that can help when you're solving these problems.